Let's say we wanted our line to go through the 2 points, -2, 3, -2, 3, and 6, -1. We could draw on that line. For most students, math tends to be their most challenging subject. Now imagine you're trying to learn this without being able to see what's on the board or read what's in the book. Imagine you can't visually see the slope of the line. You can't see the shape of a trapezoid or a triangle. How would you grasp those concepts? What would you need? What other resources would you need to make use of to comprehend those ideas?
Nationally, educational institutions, community colleges, are all struggling with how to make mathematical or technical information accessible to individuals who experience disability. And we can't wait for others to solve these problems for us, so we're digging in.
In 2011, the Distance Learning Department here at Portland Community College instituted new web accessibility guidelines for all of our new online classes. We based those standards on internationally accepted web content accessibility guidelines. However, we are discovering that some math accessibility solutions are not as simple as following the guidelines. There were many unanswered questions, which led the Distance Learning Department and math departments to fund two math faculty, release time to study math accessibility.
As a student who is blind and taking math courses at university or college level, it's very difficult because it's very visual. I feel at a disadvantage. I feel that I actually have to work 10 times harder than your average student and take 10 times as much time as everyone else to actually gather everything together and be able to study and, do what is expected in the course.
It's something I've always wondered about. How do you make mathematics, which is so symbolically and visually based, accessible to somebody, for example, who can't see? And so just that curiosity of, so what can we do, really got me interested in the project.
We want everything to be accessible, including mathematics. We would try and get everything into MathML because we believed that that was the most accessible format because it could work with a screen reader. So we were trying to get desperately for the first 3 weeks of the project, try and get everything into MathML. And then thankfully we met Maurice because he quickly told us that that's not going to be necessarily the answer, because something that we thought was the answer was actually not the answer.
The value that he added to it is just immeasurable. Without him, the project would not have been as successful as it was. It would not have been what it was. Chris and I, working on our own, thought we were headed down one path, that, screen readers, and that was the ultimate way to go, that would work for everybody. And then after meeting with Maurice once or twice, it was evident, just from talking with him, that we were so off track. Not that it's not a good way to go, but that's not the solution for everyone. And so without Maurice, our results would have been completely different. And honestly, they would have been wrong.
The first thing we tried was using MathML with reading it with an off-the-shelf screen reader. The screen reader could read it, but not all of it, and not well enough to give a good representation of what was on the screen. You have blind people who are good auditory learners and blind people who are good tactical and or reading learners. There's a difference. The auditory learners have grown up without Braille. Statistics show that only 10% of us actually read Braille confidently.
We tried a few different experiments with Maurice. One of the best experiments that we did with Maurice was when we sat down and we recorded him working with the screen reader, working with raised paper, and then working with his refreshable Braille device.
Braille worked so much better for me because I'm used to reading math in Braille just like a sighted person would read it in print.
Every blind student doesn't have the same needs. Every deaf student doesn't have the same needs. And for some reason, I don't know why it hadn't clicked before the project, But just working with Maurice, for some reason that became so much more concrete.
So each student is a unique learner, and they have their own constellation of areas in which they excel and areas in which they struggle. Some individuals are very savvy with technology, and others may need some support and assistance. So it's important for us to recognize that whether a student is engaged in a distance learning class, a hybrid class, or a face-to-face class, there are going to be varying levels of intervention that could be appropriate.
If the instructor was prepared ahead of time and had all their materials and information ready to go, and then would work with me in trying to get any type of visual information in a form that I can understand, which would be either audible or tactile.
Yeah, it really comes down to the rule of 4. The rule of 4 is something that as a mathematics faculty we're very familiar with, and the rule of 4 says that when you're presenting a concept or an idea, you talk about it in as many of 4 different ways as you can, which is verbally, graphically, numerically, and algebraically. When you're working with a blind student, then typically that blind student may be able to access the verbal part of the rule of 4. That's not a problem. But the other 3 parts of the rule of 4 can present difficulties that need to be accommodated.
Portland Community College is committed to universal design. We have many efforts ongoing to try and ensure we have fewer barriers for students whenever possible. The work of the math department is great because the rule of 4 is really a specific example of how universal design can be deployed in a discipline-specific way.
Yeah, so we came into the project thinking there was just one answer, which was MathML with JAWS, the screen reader, and we've definitely left the project knowing that there is no one answer, but there are some best practices that we as faculty can adopt.
In our collaboration, we discovered that one of the most important best practices for math accessibility and online learning is a meeting with the student, the instructor, disability services, and distance learning to identify the student's individual needs. It could be held online, in person, video conference, or telephone.
Expecting every blind person to be the same and to do things in the same way is not realistic. That's like saying every student does things in the same way. It's just not, it doesn't happen that way. And so for the school and instructors to be willing to work with individual students on their level and what they need is essential to their success as a student.
These problems are difficult and they can't be solved by any one area alone. So the way that our faculty members engaged with distance learning and with disability services and with end users themselves very directly is a model that shows great promise and that could be replicated.
I would say the biggest obstacle that I have is other people's attitudes. Other people's assumptions, other people's incorrect information about what it is to be blind or to have a disability. If people were more willing to learn and be open-minded and actually ask questions and not worry about whether it's offending someone, and just really understand that person and what that person with a disability, how they live, it actually would make them more educated, and it would make the person with the disability, feel more accepted and more on an even playing field like everyone else.